Okay, prior to learning this next thing, which is called expected value, we were learning about probability and probability trees. So, probability, again, is just the number that we want for an outcome over the total number of outcomes that happen for an event. While if we scroll down, we were talking about probability trees, and then a probability tree is a visual way to showcase all these outcomes, maybe choosing a particular one that we want, right? Expected values is not really, it is related to these, and especially it talks about what the amount that we can expect for a particular event. So I'll just say that it is um, I guess the way I can just define expected value is the amount we are expecting based on the net amount of gain / loss and the probabilities determining this net amount. Okay, so let's think about this in the game, right? So when I think about this in the context of a game, so if I think about a game, right? So let's say I just, I just flipped a coin, right? So let's say the game is I flip a coin. If I get heads, then I win. Let's say I win $2. If I get tails, I pay the dude $2. So let's say like there's a dealer. If I win, I get heads, I get $2 from the dealer. But if I get tails, I have to pay him $2, right? And then to even start off the game, so to start off, let's just say the cost to play each round was just $1. Still a lot, but I mean, hey, if I pay $1 and then I win using heads, then overall I would win $1, right? So let's just calculate the expected value. So the way that we can find expected value is through this equation. So the way that I find expected value is going to be equal to x1 times p1, x2 times p2, plus all the way to xn times p of n. So let's define each of that. So xn is going to be the net, notice how I write net gain or loss / loss from an outcome. And then P of n is going to be the probability of this outcome. Actually, I'm going to say for an event. So if we think about these like multiple events that can happen in this game, I can either win or lose, right? So maybe for this game, I'm going to draw first a probability tree. So what are my outcomes? Well, what's my event, right? So my first event, well, there's only one first and the only one event, which is going to be just flipping the coin, right? If I'm just flipping the coin, that means I'm going to have two outcomes, getting heads and tails. So that's what my probability tree is going to look like, heads and tails. In this case, I'm just going to draw what I win. If I draw heads, I win $2. But if I draw tails, I do -2, right? So what I'm gonna do right now is I'm gonna label what my x1 and my and the xn's are, right? So in this case, x1 I'm gonna say is the net gain from getting heads on a coin. So if I look at the net gain, that's going to be $2. That's how much I win, right? So this is, I won. But then I'm going to subtract that by $1. Why is that? Well, it's because the game, it says that the cost each round is going to be $1, right? So I'm going to write down as this as the cost. If it mentions cost, you'll always have to account for it, whether you do net gain or loss. When you do $2 minus $1, I overall gain $1. Let's find out what P of 1 is. So that one is the probability of getting heads on a coin. Probability of getting head. So I'm going to write P of H. Well, that's going to be 2 total outcomes on a coin, right? I can see here in the probability tree. And how many is it on the probability tree? Well, it's only 1. Okay, so I figured out what x1 and P of 1 is. So now I have to think about x2 and P of 2, right? So I'm just going to copy this because I'm getting a little bit lazy to write. Let's just say I copied it and then I pasted it. So x2 is the net gain for me getting tails on a coin, and then p2 is the probability of me getting tails, right? In this case, for the net gain from getting tails, I lose $2, right? So I lost 2. I lost $2, and even with the $2, I have to account for that $1. So this is with the cost. And then because of that, these accumulate, so it becomes negative $3. Okay, the last thing I need to figure out is getting the probability of tails. So I'm going to look at the probability tree again, and we can see here that in this case, tails is one of the branches, so therefore we're going to put 1/2, just like heads. We're going to combine these two to find out now the expected value. I'm going to write expected value as just EXP. And what I'm going to do is that I'm going to combine these things together, right? So I'm going to say the $1 times 1/2. So this is with the heads. And I'm going to say plus -3. And you don't have to do parentheses. I'm just doing it so that it can be easier. But this one is going to be for tails. So -3 times 1/2, right? When I calculate these, this is just going to equal to 1/2 minus 3/2. This just equals to -2/2, or just -1. So overall, what does this tell us? Well, this tells us this expected value means that the amount of times I'll play this game, right, I'll probably determine that my net amount is going to be negative money, right? So if I play this game and I keep on doing it, I'm going to end up with negative money. So what does this tell us? Well, there's 3 things. If the expected value is going to be less than 0, you're probably going to lose money in the long term. So notice that this is going to be in the long term. Let's just say if I played the game for just one time, and I do land on heads, right? If I do land on heads, then all I do is just win $1, right? And then technically if I'm done, then I just won $1 and I leave, right? But in the long term, if I kept on playing this game, soon enough, I would probably lose a lot of money. But if my expected value is going to be 0, then the game is probably fair. And so I'll either win or lose money. If the expected value is going to be greater than 0, then I gain money, right? And this is probably what you want to hopefully have. But not every game is situated like this where you can win in the long term. Let me just do one more example and then we can kind of finish this off, right? So let's just say I had a dice, right? So I'm going to say a fair-sided die. Oops. So I'm going to have a fair-sided dice where I gain blank dollars. I'm going to say X dollars based on the number I roll. So as an example, if I roll $5, that's a 5. I win $5. However, to play, you must pay $3. So let's just figure this out, right? So what is the expected value? So again, let's just write exp is equal to x1 times p of 1, x2 times p of 2, plus all the way to x of n, p of n. So let's just say I think about my first outcome. My first outcome is just me landing on a 1. Lands on 1. In this case, if it lands on 1, I gain $1. But then I lose to pay $3, because remember that this is the cost. Therefore, my x1 is going to be 1 minus 3, which gives me negative 2. Sorry about that. Let's think about next my second outcome. If it lands on 2, right? If it lands on 2, I'm going to gain $2, but then I lose $3, right? And again, that's also with cost. So with x2, I'm going to get negative 1. And then we have to also figure out my probability of me getting this, right? For both. Well, since I'm just rolling a fair-sided dice, all of them are equally likely. So they're just going to be 1/6. I'm going to speed it up a little bit, just because we can basically do the same thing for the rest. So I'm just going to copy it, and then we'll see what happens. Copy. And then what I'm going to do is that I'm going to erase this. So let's just say I did 3. So then I would gain 3 but lose 3. So therefore, x3 would just be 3 minus 3, which is 0. Probability of me getting 3 is still 1/6. I do it again, but this time for 4. So let's just change it. For I gain 4, I lose 3. x4 is equal to 4 minus 3, which is equal to 1. P of 4 is equal to 1/6. And then 5. Again, gain 5, lose 3. x5 is going to be 5 minus 3, which is 2. P of 5 is equal to 1/6. And the last one is 6, when I gain $6. Probably the most I'll ever gain. And lose 3. So x6 is equal to 6 minus 3, which equals to 3, which means P of 6 is 1/6. Notice how all of them are 1/6. That's because the probability tree, well, there's only one event, right? So one event, and that's me rolling the dice, which looks like this: 1, 2, 3, 4, 5, 6. Where each of them represents an outcome of me rolling the dice. So let's just combine all of this to get expected value. Expected value, so if I look at all these, I'll combine them together. Negative 2 times 1/6 plus negative 1 times 1/6 plus 0 times 1/6 plus 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6. For the sake of this, I'm just going to say that, hey, you can cancel these out instead of just calculating them. The 1/6 and the negative 1/6. The 0, it just becomes 0. So all that we're left with is 3 times 1/6, or 1/2. So that means I will at least gain some money. I won't gain a lot, but I will gain some money. So that's basically how this works, expected value. It is ultimately relying on this idea that I'm going to find out the net gain or loss from an event and the probability of me getting that event. In the case of the 6 dice, it was me getting the probability of a certain side, and then X would be the net gain or loss from that particular game. In the next one, I'm going to be talking about independent, dependent, and or as well as complement. That's it.